Nicole, can you hear me? Okay, great.
Yeah, I can hear you.
Can you see the screen too?
Yeah, I can see it.
Okay. Yep. So welcome to Lab8. Let's get started. Yeah. So do you have any questions about Lab7 or anything else? Yep. Okay. So now we're going to the HPC. This is a totally same one. So we now we're done with all the SQL parts. Then we start HPC. Okay, high performance computing. So the purpose of Lab8 is to get familiar with HPC, which is high performance computing, and Linux, because Linux is an environment, the OS system that's really specialized in the HPC or parallel computing. So you're gonna use a Linux terminal to run the high performance computing process. And we're going to learn to use HP resources for learning. Okay. So the HPC is actually provided by the CHP. Where is it? CHPC, yeah, CHPC. From University of Utah, and they give you a lot of software, which is a Jupyter Notebook to use Python or RStudio or any other like MATLAB or the software that needs the computing resources. So and also they provide the terminal to use the parallel computing, but we're gonna use it later. Okay, so they provide several clusters, which means cluster, which means the server that has computer resources. So we can use the performance. I mean, we can use the computing resources from the server. So it means we land the computing resources from the server, and then we can use the computing resources to run the code. So for today, we're going to use a notepik cluster to run our code. Okay, so here we're gonna use the computing resources from notepik server that is provided by the CHPC. So you need to go to the on-demand this website. So everyone has already accounts here. This is automatically registered by your UID. So let's go to on-demand. So just type the on-demand .chpc.utah.edu. Okay. And then please, before we start, please don't forget to download all the data from Lab8 in the canvas. So we have three data we're going to use. Run.sh file, which is a Linux command, and submit.slum file, which you're going to use for HPC, and then skd.py file, which is Python code that we're going to run in the HPC environment. Okay. It's only like about 5 kilobytes, so it's not going to take time. So what you're gonna do is remember that we used ubox before, right? Ubox is a working directory that we can use. It's also provided by the the CSPS, but here CSPC they also provided the directory, so you can go to Files tab and go to Home directory to check your working directory here. So each one has been assigned already the this drive. So you can see that there's a pathways of the directory. You can see chpc.utah.edu and /common /home and your UID. So this is the working directory that we're going to use. Okay, so let's make the Lab8 folder here. Okay, so here's a new directory button. Yeah, how to explore here is you can click the files and home directory. And if you go here, then there is maybe empty if you don't use. I have not used it before. And then go to new directory button and just hit it, and then make Lab8 folder. Okay. And then just put everything inside here. Oh. Right. So please put the, you can just drag all 3 files drop in this screen. It will work. Or you can upload. You can use upload button to upload all the data. Yeah. So like I said, we're going to use the Notepik server, which means Notepik cluster, or also you can say Notepik server or cluster. So there are a lot of servers the CSPC provides for you guys. So there's Notepik or Kingspeak or other just 1 to 10 nodes, which is no name. But you know there is a different characteristic, but you mostly you're gonna use Notepik or Kingspeak. But later we're gonna go over what's the difference later. So we're gonna use Notepik shell access to run any code. So CHPC actually provides the environment of Linux, not Windows, because Linux is good to manage the database and also the computing system and on the network. So it is really good for HPC and parallel computing than Windows, because Windows is a little bit, Linux is more open for you guys because it's open source, not like Windows. So for HPC, almost every HPC, which is CHPC, which is a high performance computing environment from any other university, use Linux to run the HPC. So yeah. So you need to know like few codes for Linux. I'm gonna go over later. So what you need to do is just put every data in this directory, okay, and then go to the next. So yeah, and here's another way to open the terminal. But in this class, we're gonna open the terminal with this. Where is it? With here. So you can open a terminal here. You can just hit the button of open and terminal, okay? And to access the Linux environment. Okay. Yeah. or you can also access the Linux terminal with these clusters. So the difference is you can start with, you can start with this directory with this button, okay, because we're gonna start opening the terminal in this directory. So if you click here in this directory, then you can see the first line shows this working directory. Yeah, so you can see this working directory starts from this Lab8, right? But if you start with the clusters and maybe the other okay, just let's pick here. Then you start from the initial working directory, so that you need to go to the Lab8 folder, right? Because there's no specification of the working directory here. But if you start with this, then you can start with this Lab8 folder. Okay, so here actually you can write the command to run any code like this. So Windows, it's like if you copy or if you move your folder or data, then you can use mouse, right? In Windows, right? You can just click and drag or click right button and copy and paste, right? But everything, those functions are also run in the Linux with code. Okay, so you can explore to this Lab8 folder, and like this, if you want to see the files, which files are inside of Lab8, then you can make a command like ls list. Then you can see the run.she and skd file py or submit slum all the data inside of Lab8. So of course you can use this code in the Windows CMD window command terminal, but it's the same anyway. Okay, so here is a basic code for Linux, like, and then it's good to memorize, actually. Okay, so like this, if you want to I'm gonna go over a few things here. So if you want to create a new directory, no, just first thing is, so yeah, you need to remember the cd. So cd is if you want to go to some other directory, you can use cd. So if you go back to the previous folder of Lab8, then you can just write these two dots here. Or if you go to the Lab8, then you can write like cd and oh yeah, just the command is no, not here. Sorry? Oh yeah, it will work too, but I just want to show the all the path. Yeah. So yeah, you can just use this way to go to the because it's this one space something, but you can this one, or also you can just use the cd and Lab8 to Lab8. Yeah. Okay. No, it's fine. Oh, that's weird. No, yeah, it'll work, but that's weird. Disco, okay. Yeah, so you can go to the Lab8 with this directory code. Okay. So you can see now you're in the Lab8 now. So okay, I'm gonna start over because it's too long. Yeah. Okay. And then there's the other code, which is the remove file. If you want to remove, okay, if you want to remove the stkd.py in this folder, then you can just use the rm and stkde.py. We're gonna remove the stkd.py, and also if you put the echo, then it's the same as the print. So you can just use anything that write anything, then you can just print like this. So it's the same as print in the Python, right? And you can use the unzip to unzip the zip file and so on. All right. Okay. So if you want to see more codes, then you can just refer to this homepage. Right. Right. Okay. So now we're gonna run the Linux command here. So for Linux, we have this .sh file, which is the it's similar to the batch files that stores the group of the codes of the Linux code. So if you open it with the notepad, or you can just click the run as .sh file here in this Explorer. Just click it, the run.sh file. Then you see this code. So this is the Linux code, right? The first line is declare this is Linux. So this is default code. And then here's the MK directory. So it's we're gonna make the directory of the Lab8 script in Lab8. Okay. And then we're gonna move Explorer to the Lab8 script, and then we're gonna pwd, which is the print working directory, into the lab8.txt. Okay, so what we need to do is you need to replace this. There should be your UID, right? So you need to replace the UID with your UID here. Okay. Yeah. Okay. So if you run this code, then the new you're gonna print a working directory and insert this working directory into lab8.txt. All right. Okay. So so how to run this batch file? So you can. So just make sure that you are now in this Lab8. Okay. So you need to go to the Lab8 with the CD, or you can start the terminal within this directory. Okay, hit the button of the open in terminal in this directory, and then just make sure that the Lab8 is the working directory now. And then you can just type bash run.sh. Okay, because run.sh file is inside of the Lab8 folder, so you can just click it. And then you can just write this command and then just hit enter. If there's no errors, then there should be lab8.txt file, new lab8.txt files created in lab8 script folder. Okay. Yeah, this code. Oh, so no, actually, before you yeah, put this to the yeah. So you need to open just with Notepad and just here. Yeah, if you didn't put your UID, you're gonna make error, of course. So again, first, the second row here is to make a directory of the make the folder of the Lab8 script, and then next row is let's explore into the Lab8 script new folder, and then we're gonna save working directory into the Lab8 file, which is created by this command. So if you run this, then you can see, and also you need to refresh it, the working directory here. Then you can see there's a new Lab8 script folder, and then inside of it, there should be a lab8.txt file. So if you open it, then there should be working directory inside here. So it prints the working directory. Is there the error occurred here? There's no issue, then we go next task here. So yeah, we just finished the second one. Yes. So we just finished running the Linux command with shell script. So we just now ran the run.sh file with the Linux terminal. Okay. And then let's jump to the third one, which is run script using HP's cluster. So we use the .sh file, right, which is the execution file in Linux. So it's similar to the exe file in Windows, right? Yeah, if you just click it and just it's like a it'll automatically play when you just execute those the files because it has the group of the commands inside. And now we're gonna run this slum file. So slum is the file format that CHPC uses. So this slum file also has a group of the includes group of the commands inside. Also, but Linux, and also you can use the Python inside. Okay, so if you open the submit the slum, I'm gonna just open it with the notepad. Yeah. So here's the what you have in slum file to run the the code. Like this is a group of the commands here. So here the first line is Linux code, right? It declares it is Linux, and then we just specify the account and partitions from notepad because we're gonna use notepad, and then job name. You can just make up the name of the job, and we're gonna name it just test. Okay, and then here's the output file. So if you have the output file from those code below here, then you can just define the output file here. So you're gonna return, export the output file as out.txt file, and then we can specify the number of tasks. So here it means how many the resource unit we're gonna use. So resource unit is related to parallel computing. So if you put like 3 or 5, then it means you're going to use a 3 parallel computing units. It means that you declare that we're going to use the parallel computing. But since we just put 1, so this is not a parallel computing, but we're going to use just computing resources from this server without parallel computing process. Parallel computing resource, without using the computing resource, parallel computing resources. Okay, so no, it's just weird. No, without the setting, without the parallel computing setting. So we could just use the 1 unit, and then this is the time set. So if you set time to 10 minutes, then this code will be terminated after 10 minutes automatically. Yeah. So okay. And here so cd is the the command that finds the directory, right? So we can just use this slum submit directory to set the directory as the directory that has a slum file. So any directory that has a slum file, we're gonna go to that that directory, and then we're gonna run the Python code with Python command. So you're gonna use the Python, and then the name of the Python script, which is aka.py file. Of course, it should be in the same folder, and then the instance variable you want to put. Okay, so we're gonna put 2000. We don't know what 2000 means yet because we didn't read this py file yet. So okay, so I'm gonna go over what is inside of this py, which code are inside this py, and then what does it mean of this 2000 instance variable there. Okay, so now we have a group of code here. I'll just submit the slum file, and we're gonna run this in this HPC environment. And before that, we need to look into the which coder inside of this stkde.py file, right? We want to run. Okay, so here is the code, and there's some. I think there's some description here, but I'm gonna just go over quickly. Okay. So if you open the py file with Notepad, and this is the code for STKD, which is the spatial temporal kernel density estimation. So when you put the points inside, then it will estimate the density, kernel density between that points, and then export the result of the density and the location of points and density. So in py file, we import all the library here, and then there's a few variables that you need to declare, which is HS and HT, and then X resolution and Y resolution and T resolution, which is the axis resolution. So okay, and then I'm gonna skip it, but here. Yeah, just do one by one. Yeah, here. So now we're gonna make an empty list, named XYT list, right? And then we're gonna append some variables in this XY list with this command. So this is an important part. So here we specify the sys.argv, right? So this is this means a system.argument variable. So the argument variable is that if you put this sys.rgv is 0, because Python always started with 0, it means that this one is the name of the script, which is stkd.py. But if you put the 1, then it means that this is the variables that you put. Okay, so because in slum file, you put 2000 here, right? So this is instance variable you declare. So this sys.rgv1 means 2000 here. Okay, so it means this is 2000. Okay, if you put 2000, it will work too. It's the same. So depends on how, depends on the number that you put. The XY list, we're gonna be different, right? The number of lists in XY list. So if you put 2000, then it means you're gonna make the 2000 list in XY list, right? If you put 3000, then you're gonna make 3000 points. So the more the points you put, the more processing you need. Okay, so and then all the code below here is for SDKD, so I'm gonna just skip it. But here, what we're gonna do is we are gonna estimate it running time. So first, after all the, okay, here. So here, first, before we run these SDKD parts, we declare the start time variable and then store the current time. Okay, and then after executing all the code for SKKD, we made an end time variable here to capture the current time after this SKKD code, and then we're gonna subtract the start time from end time and then store the runtime to save the running time, and we're gonna print it. So we're gonna print these 2000, right? Because this is argument second argument, so variable. So it will be 2000 number, which is number of points, and then here. Yeah, and then the second one is the running time of this code. Okay, and then if you print it, then the print result will gonna be saved, stored to the output.txt file. Okay, this is how it's going. Right, so we're gonna run this slum file. Okay, so how to run it? So it's in the terminal, right? Just go to the Lab8 folder. Okay, the working directory, and then the code to run the slum file is sfetch submit .slum. Yeah. Oh. Yeah. Oh, okay. But the partition name specified. I think the code a little bit. Oh, this is physical. Oh, yeah. So yeah, so because we already declared that we're gonna use a notepad, right? So you need to go to terminal of notepad here. So click here, and then go to notepad cluster. Okay, so click notepad here. Yeah, and then just make sure that their host name is notepad here. Okay, and then you need to go to the Lab8 folder like this. Okay, just make sure 2 things, and then run the sfetch submit.slum. Yeah, then you're gonna show this, this result. So if you, here, if you have an error of a Python, then I just here, if you the error shows like this, like there's no Python that comment is not found, then you should write this code here or in some file, but you can just put like module load Python to load a Python in this terminal. Yeah. And then as batch submit that file. You can run this. Okay. Yeah, these two codes. It's too small, I guess. Yeah, here. Module load Python, this terminal, and then as batch submit the file. If you face any error, yeah. Also, yeah. Like this. So if there's no error and it runs without any issue, then you can see if you refresh the here, then you can see this out.txt file, which is output. And if you open the out.txt file, there should print the points, number of points that you put, and then the running time, right? Sorry? Yeah, there might be some errors here. There's no, it's weird. Yeah, I'm gonna open the Chrome again. Sometimes it happens. Oh, in the output file there should be the result of the XY and XY file and not here. Oh, okay. Python command not found. So I'm gonna run it again here. Then module load Python and SPatch submit. That's well. Okay. So now it's running, I guess. It takes some time. Yeah. Okay, now it's running. Yeah, and there's two outputs, out.txt file and stkd data.txt. So in stkd data, I guess there should be the x, y, z coordinates and then also density variable here. But let's see. Let's see, out file is open. Yeah. Okay, mine runs well. All right. So if you open the out.txt file, then like I said, there should be points, a number of points that you put, right? 2000, right? And then also the running time, which is 32 seconds for the skdae. And then when you see this code, this code actually in Python, this code actually created another output file, which is stkde files, right? And then we store this as an out file, and it says we're gonna write some the information to out file with this command. So so in out file there should be xc, which is x coordinate, and then second is y coordinate, and third is t coordinate, which is a z coordinate, which represents the height, and then the density, right? Should be several lines, but consists of these 4 variables. So if you open the skd-data.txt file, then you can see the x coordinate, y coordinate, and z coordinate, and then density variable. Okay, for 2000 points. Okay. Except some null values. Yeah. So just make sure that two files will be exported, out.txt file and then the skd.data.txt file. Okay. Then in output, the most important thing is here the number of points, and the running time depends on how many points you put. Okay, because it's gonna be deliverable. So for submission, if you don't have errors, so yeah, for submission you need to make a graph and then give some description of it. So you can just read this, but what you need to do is make this table, which is the execution time as the data points increases. Okay, so the deliverable will be this chart with the Excel or any other software you can use. And the paragraph describes the chart and the reason for observed relationship. The relationship between the running time and the data points they put. So what you need to do is, it's very straightforward. So go to the submit.slum, and then you need to change this second this instance variable we put from 1000 to 5000, right? As interval of 1000. Okay.
Is there a more convenient way than re-uploading it each time?
Oh,
or is it
actually,
still be getting re-uploaded
so you can just modify the py file actually
within there?
Yeah. So in this py file, let's see. Oh, just delete everything. Yeah, so you can actually modify the 4 and maybe, yeah, the 1 to 5, and then the points, number of points will be the I multiply 100, right? 1000, right? Because 1000 to, oh no, it will be 6500, right? 5000, right? And then you can modify this code, and then really, yeah, you can do it. Yeah. And also there should be another way. This is
Yeah, if you want
Yeah.
to modify it in the actual
Oh, a second.
What was this for the
Oh,
It is the error on line 9. Is it? then it means the Python is not loaded. So where is it?
Yeah, you did one.
So you need to put load module Python here.
Okay.
Yeah.